Okay, welcome to part 3 of our C64 Rebrick series. Today we're going to show you how to get the components installed. Here's the Rebrick completed. Note that what we've done is we've installed LED right in the middle of the Commodore logo, which I think looks pretty cool. Originally, I designed them to look completely stealth so that they look just like a factory brick. But I was selling them at the Chicago show, and nobody knew what I had because you couldn't tell that there was anything different. So the LED was kind of a, hey, look, this is something different. And then when I did it, I decided it was pretty cool and decided to stay with it. The second thing came from conversations with folks online, and that was, hey, how about a fuse? And initially, the first couple of prototypes were fuse installed internally, and then I tried a panel mount fuse, external mount fuse, and I really like the look of it. I like that kind of tactile. I can take a fuse out and change it. Most people know that if a fuse blows, there's a reason for it. You don't just swap them out indiscriminately, but at least it gives you that kind of feeling of safety, and it provides quite a bit of safety. So if something were to short out in there, the fuse would blow rather than electrocute you or burn your house down. At least that's the hope anyway. So the fuse holder we're using here is from Jameco, little panel mount fuse, and the next step here is we're going to show you where and how to drill the hole and how to get this installed. So, those of you who've watched part 2 may notice that this isn't the same power supply. Sorry to change it up midstream, but I went through the build process far too quickly and didn't get much quality video. I also want to point out this metal bracket that we now have over the transformer. This case is slightly different than the other ones I've worked with, and the area for mounting wasn't as flat as I like. So I added this bracket to give the transformer, show it to you here, to give the transformer a bit more solid mounting. You can see what I used here is a PC slot cover that's bent into place over the transformer. I also gave in and put in one screw to help hold it in at this corner here, and I hope that doesn't ruin the aesthetics too much. Okay, now we're going to show you how to drill the hole for the fuse. I know drilling holes is pretty basic, but I wanted to show you where I put it. We're going to have to drill a 1/2 inch hole that is actually oval shaped, and I put it about 3/4 of an inch in from the edge and right in the center, top to bottom. So we're going to drill a pilot hole here, and I'm going to try not to slip with the drill bit like I did earlier. So there's our pilot hole, and then we're going to switch to a big 1/2 inch drill bit. First time I drilled this, I was horrified that I was putting such a big hole in one of these cases. This is what we need, though. You can tell my drill bit is dull. Okay. So what we'll need to do is we'll need to elongate this hole slightly, and I just do that with an X-Acto knife. So we'll get that done. I'm not going to record that. It's pretty basic. I'll show you the hole and show you the mounting. Okay, so what we're looking at here is kind of the setup I use to mount the fuse. We want to fuse the hot side of the line, okay? And so we measure that. We check it out on the ohm meter to make sure that we're going to fuse the correct side of the AC cord coming in. So we want to fuse the hot side. I'm going to connect the hot to here, but we want this sleeve of heat shrink over the end of the whole thing. So we kind of have to thread it in place, and then we're going to put the wire out through the hole here so that I can solder it in place, and then everything will come through the heat shrink when it's done. I kind of wanted to show that because I wanted to at least mention about fusing the hot side. So here we have the fuse holder soldered in place. You'll see, if I can zoom in on it, we have one input and two outputs. One output goes to the 9-volt AC transformer, and the other output will go to the 5-volt switcher. And all these wires are going to feed through this piece of heat shrink, which will help protect it from exposure to the line voltage. Or I should say, it'll help protect you or me from exposure to the line voltage if we're in there working on it. So here we are with the fuse mounted in place, the heat shrink in place. The input side of the fuse is on the bottom, or I guess what will be physically on the top, but the point is for the input side to be not exposed. The output side is this wire here. This is what's going to go to the 5-volt switcher, and then this is the other side of the line. We're going to connect to the 5-volt switcher, and that's the neutral side. Okay, next we're going to prepare our LED. I'm using a blue LED, but you can use any color you want, and I'm using a 560 ohm resistor. 470 is usually the value you use when you're stepping down from 5 volts, but the blue LED is really, really bright, and I found that 560 tones it down just a little bit. You could probably go higher on the resistance and get the blue toned down even more, but this is the choice I've made. I usually tack the resistor to the negative side for resistor polarity. No, that's a joke. I always do it the same way so I remember which side is which once I've cut the leads off. So we're just going to tack this on. Pretty straightforward. Doesn't require a lot of strength because we're not going to put it under any strain, and we're also going to cover it with heat shrink. So and sometimes the heat shrink goes down on the resistor with no problem, and sometimes it gives me trouble. Naturally, since I'm recording, it's going to give me trouble today. But you get the idea that when we're all done, we'll have the heat shrink all the way down. I'm not going to record myself cursing this, putting it down on the leads. So there you have that. Expletives uttered, heat shrink installed, and we're ready to install this LED. Okay, so now we're going to drill a 7/64 hole for our LED. 7/64 inch drill bit is the size I use for just about everything in this project, except for the fuse holder, of course. And I've already put a little divot in so my drill bit doesn't walk. This case is much thicker than most of the ones I work with. Commodore used a lot of different suppliers, and the quality varies widely. So I've noticed when I'm drilling holes that some are easier to get through than others. So I can test fit this, make sure it goes in. It's a little bit tight, but that should still work. I might ream that just a little bit. Give myself a little bit of flexibility. Now we're going to install this down here. Kind of press it in place with a screwdriver. And my hole, I don't think, is still quite big enough because it's having a hard time getting it in there. Let's have a look on the other side here in a moment. We'll find out. I don't want to break the LED. Yeah, see, that's not coming through quite enough for my taste, so I think I'll drill the hole slightly larger. Okay, so we've got our resistor in place. Got it held in with a little dab of epoxy. It's 5-minute epoxy, so it'll dry pretty quickly and we can move on. It turns out it wasn't the fact that my hole was too small. It was this case, this particular case. The plastic is so thick, the LED just didn't come through any further than that, so I left it alone. Now we move on to mounting the 5-volt switcher. Okay, so here we have our 5-volt switcher, and we're installing little plastic standoffs to the bottom. I'm just super gluing those in place so they stay put. That's to space the board up from my nylon mounting brackets. And then this bottom corner here, which you can't really see very well, in this bottom corner is our ground wire, and I do solder that to the ground lug so that it stays put, and it doesn't space out perfectly, so we're going to use a little metal washer here to get that spaced out so it matches the rest of them. So here the power supply is sitting down on the nylon block. The reason for the nylon block, I don't know if I ever explained it before, was to give us a good mounting surface, and it's easily drillable, and it accepts a sheet metal screw and self-taps. So what we're going to do here is we're going to drill, and I'm completely on the wrong side because I'm left-handed, but we're going to try this. I'm going to drill pilot holes here. Probably can't see that corner, but bear with me for just a moment. And the last one. So now we're going to take, and we're going to, since we took the power supply back out, we're going to drill these holes all the way down to the bottom of the block. So I'll show you that in just a minute. Okay, so now we've got our holes drilled. I do drill them by feel, but the trick that someone taught me to drill a hole where you don't go too far is to put a piece of masking tape around the drill bit, so you only drill to the tape. So we're going to set our power supply down in place. These standoffs that I purchased don't like to hold super glue very well, so they tend to fall off. Not quite as good as the last batch I purchased. So we're going to use a pair of pliers, needle nose, and just drop those screws down in there. No, actually what we're going to do is we're going to remember the washer first. And I know you can't see that completely. And that washer just sits on there. You could probably glue it in place just so it stays put. I'm putting the screws in the holes up here first. Because the other way wasn't working very well. And we'll find the holes. Tighten those screws down. This was all based on the idea of the power supply being repairable. Switching power supplies are not particularly repairable, so the fix, if this switcher were to go out for any reason, would be just to simply replace it. But since we've got screws in place, that makes that relatively easy. So we've got that solid in place, and all we have to do is solder some more connections and we'll be done. Okay, we're getting the AC side soldered and connected, and I wanted to add something that I'd forgotten to mention. I get the power supplies, the 5-volt switchers from Jameco. Oddly though, Jameco does not carry these. That's the little connector that snaps into place on each side. So there's a 3-pin, it doesn't actually have 3 pins, but it's 3-position on the AC side, and a 2-position on the DC side. That's this one here. And Jameco doesn't carry those. I had to buy those from DigiKey, so it's kind of bizarre that Jameco carries the power supply but not the connectors. You can, of course, solder the wires directly in place, but that kind of gets away from the repairability of it, so I decided not to. So we're soldering these individual pins on. I know those are a little bit hard to see. I don't crimp anything, so everything gets soldered, and then they snap into place here, like so. And finally, down onto the connector. And they're a very positive connection. Once they're on, they don't come loose. I really like that locking mechanism. Okay, wrapping up the electronics portion. So we reattached the original C64 output cable, and Commodore didn't usually use standard color coding, so always check your wires to make sure they're correct. Usually brown is +5. In this case, the +5 actually was red. The cables were a little short. I had a nick in one of the cables, so I cut them short and added a little extension. And then our LED, if you can see that, our LED is piggybacked onto our 5 volts, which is why we needed the resistor. So the LED is piggybacked onto the 5-volt connector. And then our 9 volts AC, we got one side connected directly to the transformer, and the other side is going through a 2-amp fuse. The choice of the 2-amp fuse was a little bit arbitrary, I admit. I've taken apart some of the bricks, and Commodore used apparently whatever they had handy. I've seen 1.5 amp up to 3-amp fuses in those bricks. So I think 2 is a good compromise, where if you have a little surge, you don't blow out a 1 amp right away. We know that the current capacity of the transformer is 1 amp, but I think that a 2 is probably a good compromise. Maybe even 1.5 amp might even be better, but I don't have any handy. And then on the line side, I'm using a 1 amp fuse. Both fast-acting fuses. So this is what it looks like. I will get some zip ties and tie these wires in to make them look a little bit nicer. And then we're going to plug it in and we're going to see if it works. Okay, so now we're going to plug this thing in and see if it works. Hey, we got light and we got 5 volts. That's perfect. Let's look at the 9 volt AC. My little tester doesn't have a AC voltmeter, so I just use my fluke on these test connections right here, so we can see what we've got. That looks good. That is loaded, by the way. I've got a resistor in there that gives it a little bit of a load. It looks like we're working. Let's try it on a regular C64 and make sure it works on that. My workbench is a terrible mess. Switch that to pass through. See, the voltage goes up a little bit when you're not loaded. And we switch it on. Hey, there we go. I was starting to get worried. There's my Easy Flash 3. Turn this light off so we don't have so much glare. Oh, I guess it wasn't that light that was causing the glare. Play a little Prince of Persia. And that about does it. When I build these, I burn them in for several days before I let them out the door. One last thing. You can build these yourself, of course. That's what the point of this video was. And you're going to have some of your own ideas. Mine are not necessarily the only ones. I have one last thing that I want to add, and I'm not prepared, so let's come back. Okay, so here we are at the end of this process. At this point, if you want, you can put some silicone RTV around the edges of this and put something heavy on it and let it seal up, and that's good enough to keep the cover on. But what I've done, in keeping with the idea of having the power supply be repairable, is take one of these nylon blocks, cut it into 4 pieces, and epoxy it into the corners here. Once the epoxy's dry, we take our 7/64 drill bit and drill straight through the bottom of these feet into the blocks so that we've got a spot for screws. And then we use a number 4 by 3/4 inch long sheet metal screw, and we thread it. It'll self-thread right into those blocks. The only gotcha is that have to trim the heads down. I use a grinder to trim the heads. I just turn the grinder on and just spin the screw to make the head a little smaller, so that the screws, when you tighten them, will fit down into... I know you can't see anything right now, but give me just a minute and you'll see what I'm talking about. They will sit down inside these feet so that they're fully recessed and they don't scratch any surfaces when you've got the power supply right side up. there you have it. All done. Hope you enjoyed, and appreciate your comments.